All right, well, let's get going. Welcome to the second computational session and the fourth lecture. After today, we're halfway through this course. Exciting. And while I'm talking, feel free to download your in-class notebook. I have a cleaned up version of the data table, the protein coding genes table we use, and just so we're starting from the same place, download this, launch your IPython notebook, open up the notebook as we go. All right, so we're going to get that. Now to start with, I just want to review one issue that came up during the last computation session. Here we go. So if you remember, one of the key points, key concepts from the last computational session that was that our data, our genomic data is stored as plain text files. And so we went to the UCSC genome browser, we downloaded a text file, and that was a bit of a sticking point in some cases. Different browsers behave differently, and sometimes you don't always get a plain text file. And so one thing you need to do is confirm that the text file you downloaded is correct. So I just want to show you an example of something that caused problems. I'm going to show you, here's an example of the gene table that we downloaded from the UCSC browser. This might be a little hard to see, but this is now in rich text file format, which happened to some of you. I don't know if I can zoom in very much here, but if you look at this, it doesn't have that plain text Courier font. It looks a little fancier. It has the .rtf. It's a rich text file. It allows formatting. You can have bold. You can have italics here. This is not the correct format. And so let's take a look here. So we'll demonstrate what goes wrong here by looking in IPython. So we can open up our IPython dashboard here, and this dashboard can open text files, but all the text files are shown in a plain text view. So let's see. Take a look here. This looks like our table. It's a little hard to read, but those are the convoluted column headings at the top. Then we have all our data. So if you look at this, it looks okay. But if you open this up in your IPython notebook, we'll just click on it. I'll zoom in here a little bit. You can see all that garbage up there at the top. Those are actually formatting codes for the rich text file format. So when your script tries to read this rich text file format, it's going to look at all of that and try to interpret that as your data, and then you get an error. So this is just to sort of emphasize why it's critical to have a plain text file. And so in both Mac and PC with either the application text edit or Notepad, it's pretty easy to switch back and forth if you happen to have a rich text file format. You can go to the format menu here in Mac and say make plain text, hit OK, and look at that. So that obviously looks much more like plain text, and we save it. Now let's go back, let's close this. We're going to open it again here. And now it looks like what you want. You don't see all that awkward formatting code at the top. So just be aware this is one of the problems that you could run into when you're accessing data. There could be weird formatting things. So a way to check that you're actually trying to load what you think you have is just open your file in your IPython notebook or a text editor and see what it looks like. All right. Very good. Let's go back here. All right. So if you think back 2 lectures and recall what we did, we downloaded a table of genes and we sort of experienced the power of Python to work with large data sets by, in a fairly simple way, calculating the 3' UTRs. Some of we just used the functions, we got the task done. Some of that may have seemed a little mysterious because we really didn't go down into the nitty-gritty of how all of the commands necessarily worked that you use. So today we're gonna delve a little more deeply into the commands. You'll learn a little more how A little more about the mechanics of how it works, the logic, the syntax should make sense, and then we're going to add some new concepts. So I have 3 themes I want to discuss today, just to anticipate. We're going to talk about cleaning our data, which is an important thing to do in any kind of data analysis. And as we do that, we're going to review some concepts. We're going to look at for loops, but we're going to use them in a slightly different way. This time, we're going to again go into the details of indexing data frames in pandas, and then we're going to learn about conditional statements. In the next section, we're going to do a little more. I know there's a lot of, it's easy to get confused when you see all these parentheses, brackets, curly braces. It doesn't always make sense why you use one. So today it should make sense because we're going to delve into when you use what, and to understand that you really need to understand different types of variables in Python. And then finally we're going to build on what you worked on in homework 3, and we'll start introducing how to plot data, and then we'll come back to that in future tasks. Okay, so I want to start with an important concept in cleaning data here. So this is from an R programming book that I like to rely on. The author says 80% of the effort in a typical project is spent on finding, cleaning, and preparing data for analysis. Less than 5% of the effort is devoted to the analysis itself, and the rest of the time is spent on writing up what you did. Cleaning data is really sometimes quite a big job, and I want to give you some tools today to do that. So if you think back on the table we downloaded, we calculated these 3' UTR lengths. It seemed pretty easy. It seemed like we didn't have to do much data cleaning. But let's think back on that table for a minute. Did anybody notice anything weird about the 3' UTR lengths we calculated? Or anything strange about that table? Anything stand out at you when you looked at it? Here, let's go back to the table here. I'm going to open up I have a scratch notebook. Feel free to come along, open up just a blank notebook if you want. So as you can see, I've imported pandas. I imported the PC genes table that you just downloaded. And so let's look at this table here. Here's our table. This should be legible to everybody. If it's not, raise your hands and shout. Okay, so we have the entries, we have our names. These are the standard gen code names. Anybody know what the strand column indicates? Yeah, that's right. Genes will be encoded on either what's identified as the plus strand, or if it's on the minus strand, then it's in the reverse direction, right? Your chromosomes start at nucleotide 1 and go on to whatever for chromosome 1. So you have sort of this, it was arbitrarily chosen, but you have this left to right, or 5' to 3' orientation on the plus strand. Genes are encoded in the reverse strand. Well, okay, let's look a little closely here. Here we have a bunch of plus strand genes, and let's see how they work, right? So you have your transcription starts at this position on chromosome 1, and the number for transcript end is higher, right? That's what we expect. You start at a low number, you end at a high number for the plus strand. What do you expect for the minus strand? It should be the other way around, right? Well, let's zoom down and find a minus strand gene. So you expect it to be the other way around, but let's look at this one here. It starts at a low number, and it ends at a high number. Right? So something's already funny here. So basically the convention in the UCSC genome browser is, regardless of your whether it's a plus or a minus strand gene, it just gives the coordinates from the 5' end of the plus strand to the 3' end of the plus strand for the gene. So if you want to make calculations or analyze your minus strand genes, you actually have to reverse these numbers. But we didn't do that when we calculated our 3' UTRs, right? So you would kind of expect that you should have seen, if these if the coordinates were set the way you would intuitively expect it for reverse strand genes, you should have seen negative numbers for your UTRs if we were calculating the correct thing. But in fact, we didn't. So what does that mean? What does this column that we call the 3' UTR column actually contain? Is the 3'? Yeah, so for the minus strand genes, it's the 5' UTR. Right, so there's a mix. So we have a problem here. So this is, I call this kind of an example of data cleaning in the sense that the data is not exactly in the format you wanted to use it, right? So we got to go back and recalculate this properly. So that's one of our tasks today. All right. And now we're going to introduce some new concepts so we can figure out how to do this. All right. So as we prepare to write the code again to properly calculate 3' UTRs, I want to introduce a concept called pseudocode, which is very important when you're thinking about how to achieve a task when you're programming. Basically, it's simple. Write out the exact steps that you want in English. Right? You got to be very precise. Every step you want the computer to carry out, and then translate it into Python. So it's very useful. It helps your thinking as you start to write code. You shouldn't just sit down and immediately start thinking about the syntax and, oh, I got to look up how this particular syntax works or that. No. Clarify your thoughts by writing in pseudocode exactly what you want to achieve and what steps the computer should do it. And then it should be relatively straightforward to implement it. A lot easier. Let's see. Okay, and I'm going to introduce one more concept, and we'll call these conditional statements. And I'm going to illustrate the conditional statements with a comic. If you're a fan of XKCD, you may recognize this, but this is sort of a flow chart here. So a flow chart is basically a series of conditional statements. You start, right, and there's a question. And you can branch off in two directions. If the answer is yes, you perform one action, like in the first, right here, right? This first question, do you understand flowcharts? If yes, then you move over here. If no, you move that way. So essentially, this is a series of nested conditional statements. If this, then that. And that's it's a key programming concept, right? So think about how we're going to apply this to our UTRs. We want to look at our table and say, if it's a plus gene, we're going to calculate the 3' UTR this way. If it's a minus gene, we're going to calculate it this way. And this is great. You can get lost in this particular flowchart here. All right. So that's enough with the slides here. So go ahead and load up your Lecture 4 in-class activities. And so we'll do this a little differently from last time. We're going to start the activity together. We'll walk through it here on the board, and then we'll hit a certain point, and you're on your own. We'll see if you can figure it out. All right? I guess that's kind of legible. Great. Let's see. Should I try? Let's just try this on the board for a minute. Okay. So let's just think through our data table here for the 3' UTRs. I know this may seem simple, but let's just make sure we write down our thinking. So we're going to have a table where we have strand, and it'll be plus, minus, etc. We're going to have the transcript start, transcript end. We're going to have the coding sequence start and the coding sequence end. Let's just make sure we think through this. Okay. So there'll be some number in here. So if you want to, and now we want to calculate, I'm running out of room here, so I'll put it over here. We want to calculate the 3' UTR. Okay, so that's our table. So for a plus strand, what number do we subtract from what number, what column here? All right, transcript end minus coding sequence end. So we want a positive value, right? So we take the larger number and subtract it from the smaller number. So this would be tx end minus coding sequence end. Okay. Did I do that right? Does that make sense? Okay. How about the other one? Okay. And then you do that for the plus strand. Now for the minus strand. what do we write here? Because we want a positive value for the difference.
Wouldn't it be the other way around?
Yeah. So it's coding sequence start. I know this is not a complicated concept, but it's easy to make, dumb mistakes when we're writing our code, and if we don't sit down and just make sure we think through this, right? Minus transcript start. All right. So basically what we want to do is we want to go through our table. We're going to go, we have our table one by one, and we're going to ask, is this a plus strand gene? If it is, we want to subtract this column from this column, right? And then we keep going row by row, and then we want to ask, is this a minus strand gene? And if it is, then we want to subtract this column from this column, all right? So that's what we want to write in our code. So let's, back on the board here. Let's write this in pseudocode now. Let's state exactly what we want. So I'll give you an example of how we might do this. So go ahead and try it yourself as we go along here. So we'll start typing it in this space. So what was the first statement that we want to make? Think about for loops. How would you say it in English? Somebody shout out what we're going to. Well, let me give you an example. So, for each row in data frame. How's that? There's some pseudocode, right? For each row, data frame. Right? So, we're going to take them row by row. That's what our for loop does. Now we want to write something else. So, what should be our next statement? Anybody have an idea? Yeah, if strand is positive, right? So I'm going to space it a little bit to sort of match how the Python code is going to be eventually. That's why I'm doing it this way. But so we hit, right? You have your for loop, you have your block. Now, if strand is positive, so pseudocode, we can kind of, that's why it's called pseudocode. We can kind of make it look like code. Okay, what's the next statement? If strand is positive. Okay, yeah. TXN minus, what was that? CDSN. Great, good. Now, so if we wanted to write this in English for the next statement, I mean, this should be obvious now. Else, right? If strand is negative, right? Then we wrote it out here so we're not confused. X start minus coding sequence n. All right. Did I? Oh, sorry. Getting ahead of myself. TX start. Okay. We're almost there. Yeah, right. We're missing. We haven't assigned this to any 3' UTR thing. So let's go back in here, right? And you could say, well, we'll get into how we'll do this. So we could say 3' UTR equals, right? So this is pseudocode. You want to write it in English, but we want every step out there precisely. So you want to assign it to your variable, right? 3' UTR equals. How's that look? Yeah, that does it, right? That should do it. That's the code we want to write. So you already know most of how this should work, right? We went through for loops. Now we're going to introduce these conditional statements. If something is, right? If some condition is met, if this is true, then you go in and you perform this action, this block. And as you'll see, the way it usually works in programming, else if, so if this first statement turned out to be false, then you move on here. Else if this strand is this, so if that statement is true, then you execute this action. Okay. Any questions? That's pretty straightforward, right? All right. So let's move down a little bit. So we're going to break this into several chunks here. And as you can see in this activity, in the text here for the activity, I've written, we have three sort of things now. Now our job is to turn this into Python. We need to actually have Python syntax. So let's think about the syntax for the parts. For part one, we need to use a for loop. And if you recall, let's see. Yeah, we'll get in there. We'll move down here. We need to use a for loop. We need to be able to index properly so we can identify the columns, transcript N, coding sequence N, 3' UTR. And then we need to know the syntax for the conditional statements, for the if statements. Okay, so these are 3 items that we're going to need to do here. All right? Okay, so proceeding down now in the activity, I've broken down each of these activities into tasks. So here's your chance to break out the groups, work by yourself, and I'd like you to complete the activities. Sort of, you'll learn the syntax for each of those tasks, and by the end, you should be able to write the code you need to correct our 3' UTR values. Any questions? All right, go for it. Yeah.
So should we do the more indexing and pandas before we do those cell one?
Yeah, sorry, this is just a random cell I think I didn't take out here, so ignore it.
Okay.
So let's move on, start at more indexing in pandas.
Okay.
And feel free to add cells as you need them. These code cells aren't necessarily exactly what you need. You may want more, you may want less. So add them in as you need them.